Hey guys, it's Mr. McHugh. I'm bringing you a video on graphing quadratic functions, and there are a number of things that you encounter in everyday life that has a certain shape like a satellite dish or like the reflective cone that's around a light bulb in a flashlight or in a car's headlight that has a very specific shape that is called a parabola. And one of the things that we can do to investigate that shape is talk about what is it, how does it work, what is its shape like, and how can we use quadratic functions to get that shape by graphing. So this lesson is going to walk you through steps graphing in both standard form, which is this first form, which looks like having the equation in y equals ax squared plus bx plus c form, or graphing in if the equation is in what's called vertex form. And you'll see these two examples here. Here's the one equation that's in vertex form. In vertex form looks like y equals a times the quantity x minus h squared plus k. And the other equation example right here is in standard form. And one of the biggest challenges that we face right away is just identifying what the coefficients a, b, and c are in standard form. So for the example that we are doing, let's try that again. The example that we're doing right now, you can see the coefficient a in front of the x squared is a 1. The coefficient b in front of the x is a 4, and the coefficient c, the constant by itself, is 1. And so in standard form, the second step, once you've got your equation or you've recognized that it's in standard form, is to find what's called the axis of symmetry. And that axis of symmetry is going to be that middle line to the graph, and it has a formula: x equals the opposite of b divided by 2a, and that's where identifying your coefficients comes in handy. So for our example that we're working with, we've already identified that b right here is a 4 and a is 1. So in our equation, we're going to take the opposite of b and divide by 2 times 1, which evaluates to negative 4 over 2, which simplifies to 2. So negative 2. X equals negative 2 is what's called the axis of symmetry. Now, that axis of symmetry is going to help us in part B of step number 2 find the vertex. And the vertex we can figure out by plugging the answer that we just got for the axis of symmetry into the original equation that we started with, and that's going to get us the y value. Since the x value in the axis of symmetry is negative 2, if we plug in negative 2 and square it, plus 4 times negative 2 plus 1, all I'm doing now is I'm going back to this original equation and I'm substituting in this x equals negative 2 in each of the places for x. And when we simplify for y, we get y equals negative 3. And so the vertex is the point negative 2, negative 3. Once you've established the vertex, we're going to create a table of values, and we're going to use that vertex right in the middle of the table and pick a few values for x on either side of that. So the vertex is right here, negative 2, negative 3. I'm going to pick a couple values of x before negative 2 and a couple values of x for after negative 2. I'm going to plug each of those x values in to the original equation to figure out their y values. Why don't you pause the video and do that, just like we did with the vertex, and then resume the video again when you're ready, and you'll see my y values appear. Okay, now you see the table filled in. Hopefully those y values match what you came up with. And the last thing we're ready to do is to plot the points and connect with a nice smooth curve to get that parabola shape we were talking about at the beginning of the video. We start with the axis of symmetry, which is a vertical line. This is not actually part of the graph. And then we're going to plot the points from our table of values, starting with the point -4, -4, 1, excuse me, -3, -2, -2, -3. Now this is our vertex. -1, -2, and 0, 1. You'll see at the vertex that's the lowest point of the graph, and the rest of the graph curves upward like this, and this is what is called a parabola. Now I have a couple examples for you to work on. I'm going to get you started on this first one with help identifying your coefficients. The first equation is in standard form, so if you recognize that this is in the y equals ax squared, let's try that again, ax squared plus bx plus c form, you'll be able to identify your a as 2 right here, your b as -4, don't forget the negative sign with the 4 here, and then c is also -4. So take a minute, pause the video, try and work out the axis of symmetry vertex table of values and graph on the graph given, and then check back in to see the final answer. Here you'll see the final answer with an axis of symmetry of x equals 1, vertex 1, -6, and you'll see the table values with the points around it. At the beginning of the video I said there was another form, vertex form, so let's go back here to the first slide and look at the vertex form side of this. And given the equation that's the example, let's identify our a as 1, our h is actually -2, and our k is -3. H is -2 because you can see in the formula x minus h, if h is -2, x minus -2 gets us our x plus 2. So h is always the opposite of what it looks like in the parentheses. This is the hard part. The hardest part of vertex form is identifying your a, h, and k, because we can identify the vertex and the axis of symmetry directly from these values. So the vertex is as easy as saying the point hk. That's it. So if you look up above, our h is -2 and our k is -3. That's the vertex. We didn't have to do any work. We've got it right from h and k. And the axis of symmetry, if I abbreviate it that way, axis of symmetry is just x equals h. And we know what h is, so x equals -2. From vertex form, it's easy to get your vertex and your axis of symmetry. You'll notice now then with that vertex, I've made actually this vertex form equation is the same graph as the standard form equation, but you would proceed with step 3 of creating your table of values and then plotting the points on the graph. You would do those exact same last 2 steps if your equation was given to you in vertex form. All right, one last example here, and we'll do it like we did before. I'll get you started. This is in vertex form, you'll notice. And that makes the first 2 steps really easy once we've identified that our A is -1. Right here you can see the negative, that's a -1. Our H is the opposite of the way it appears in the equation. It looks like -3 in the equation, so H is +3. And then there's actually nothing being added after the parentheses, so K is 0. With that A, H, and K, pause the video here, figure out your vertex, axis of symmetry, table of values, plot the points and draw the graph, and check back in when you're done to see if your answers match. So here you'll see the vertex, axis of symmetry, table of values, and this downward opening parabola. Hopefully that matches your graph. And that's a lesson on graphing parabolas and getting that same curve that we see show up in satellite dishes and flashlight reflectors.